So good evening to the participants of today's session. We have our head of the department of mechanical engineering, Dr. Ravikant sir. Sir, I request you to,
Sir, good evening, sir.
I request you to please start the session, sir. Thank you, sir.
Okay, thank you very much, sir. Uh, so, welcome to this session of faculty series. I'm very thankful for giving me this opportunity, first of all, for the CRI team. Why? Because I'm intended to give a lecture for first year students because the basics they are needed, and rightly now I have an opportunity to share my views to the first year students. Okay, so
Thank you, sir. Good evening, sir.
sir, is my voice is audible?
Clear, sir. It is clear, sir.
Can I go ahead?
Yes, sir. I'm good.
Yes, sir. If you can go for full screen mode, sir.
Full screen. Right, sir. Okay. Now is it clear, sir?
Yes, sir. Yes, sir.
Okay. Basically, manufacturing is derived from a Latin word called as manufactus. Manu means made by hand, and factus means the converting of raw materials into useful products. So, in olden days, all products were made by hand only. Now we have some sophisticated machines like NC machines, CNC machines, and other robots. With that, we are going to complete the process. But in olden days, all the products were made by hand only. Because of that, it is named as manufacturing. So actually, manufacturing basically it is an activity of making goods and articles by hand. So what we can say here is we can derive this process into two categories. One I will call it as a primary process. The other one will be secondary process. The process of involving, mean what we can say, changing the raw material into semi-finished products are called as primary processes. And for example, you can take casting, you can take rolling, you can take forging, you can take extrusion, and all these are called as a primary process. Why? Because just we are converting from raw material to to an extent possible, but it is not in finished state. The process such as machining, finishing, that means intended to obtain the final products with accuracy. That means whatever the desired shape and size, the surface finish, and all those are called as secondary processes. Okay, so why the study of manufacturing process? The designer and the drafter must have a working knowledge of the various process that could produce a part in order to make the lower cost and reduce the production time. You take any other manufacturing process, okay? So when it is in number, then we can reduce the price to the extent limited. So that is the main aim intended here. So now, basically, as I told you, there are many manufacturing processes. We have casting is also a process. So what we are doing in casting? Casting is a process where we can do some making a pattern with some suitable material, and then molten metal is allowed it to solidify, and the rough casting is now ready for the machine shop. How initially it is based? So first it is preparation of a pattern, then making of a mold, then pouring the molten metal into the uh, cavity, and then preparation of mold. After then, finally, then comes in fettling or cleaning process. But anyway, we can do casting process in a very simple, and this may not be useful for first year students, but it comes under basic manufacturing process. Okay, the rough casting is now ready for the machine shop. Holes are then bored and drained. Tap and bottom surfaces are machined. Smaller holes will be drilled and countered. All these are secondary operations. So initially we are making this rough casting. This is called as primary process, and after machining, and we need to have the desired shape. This is called as a secondary process. Okay. Similarly, in forging also, we'll have primary forging operations. Then we are converting it into the desired product. Forging is also a primary manufacturing process. Then welding. This is also similar, and it is also called as a primary manufacturing process. And what are the materials that we can use? We may use metals. Now recently, plastics has came into existence, and in turn we have inorganic materials also. So that may play a vital role nowadays. And even fiber reinforced plastics, these are replacing the entire concrete structure. You cannot imagine, very light in weight, and it is also constructed for under sea bridge. Okay, there are many more things which are going to come under this tremendous manufacturing of processes. Then the materials will be classified as, about ferrous and non-ferrous alloys, and those are not necessary. And carbon, of course, ceramics, these are heat treating, annealing, all those things. And here we can come to this. Plastics are divided into two, very well, thermoplastics and thermosetting plastics. And once becoming permanently hard and uncomfortable when once subjected to heat, thermosetting cannot regain its shape and size, and you cannot even remold. But as compared to thermoplastics, we can reuse it again and again. So most plastics are of thermoplastics, and even nowadays thermosettings are also having its importance in many industries. Now, the typical plastic processing operations include extrusion, blow molding, injection molding, thermoforming. Extrusion is nothing but a toothpaste analogy. What we are doing is we are giving a pressure ram at the outside. In the extension, we are going to get a billet material, and whatever the required shape with the die we are going to get. Through blow molding, we can make plastic bottles, and injection molding is also playing a vital role. We can use different types of products through injection molding through plastics by changing the pigments. And thermoforming, I think you might have observed earlier, gas wool is going to use in a refrigerator system where for insulation purpose. Then thermoforming is going to play a vital role in making all these things. But my intention is just to show you all these things. But this is injection molding, this is blow molding, how we can make plastic bottles, and the different thermoforming. This is forming through a liquid, and it make it very hardened within no time. And of course, blow molding, injection molding. So my intention is to come here for this workshop, basic workshop. So the students of first year is not now already, if we take KSRM College of Engineering, and we are having some bitter experiences with the students. So already this workshop practice is completed by the students of computer science, similarly the students of mechanical engineering. But even after completion of all those things, they could able to produce the product, but they don't know what are the tools which are required, and what is the purpose of the tool, which tool will be useful for them, like that. So in order to gain good basic knowledge in manufacturing process, a student entering into the first year of engineering degree should undergo a course on workshop practice. It is essential. So in order to have a balanced overall development of budding engineers, it is necessary to integrate theory with practice. And also, the general workshop practices are included in the curriculum in order to provide hands-on experience. This is most vital about the use of different engineering materials, tools, equipments, and process that are common in the engineering field. So, why I am intending to make this session only to first year means They are very poor, and they are I'm very sorry if I'm giving it in another direction, but people are unable to know the tools even and the purpose, what are the uses, even after completion of their entire workshop, by spending of hours together. Besides the above, the development of dignity of labor, precision safety at workplace, team working, and development of right attitude are also very important. So we are coming now. If we can come, we are giving some energy. So we are taking the input material, and some heat is of course liberated. Now in case of carpentry, it may not happen. Some maybe in case of some other machining process, heat may be allowed evolved, and then output of the material. That's of course. Workshop practice gives a basic working knowledge required for the production of various engineering products. This you should keep in mind. And the application of different working tools, equipment, machines, as well as the technique of manufacturing a product from its raw material is to be known. For example, if you are making mortise and tenon joint, if you are making lap joint, if you are making butt joint, what is the purpose? Why it is necessary? What is the tools which are required? What is the material that which you are going to use? All these things are very important for the subject point of view. And what are the trades usually in any engineering colleges is we have different types of workshop practices. Particularly, we have carpentry, we have fitting shop, we have electrical shop. Similarly, we have sheet metal shop. Similarly, we have welding shop, and we have different workshop practices. Coming to carpentry, what is carpentry? If you can say, it deals with the process of wood to obtain desired shape and sizes. Okay, and what are the tools here? We may have for marking gauges, for measuring purpose, for cutting purpose. We have cutting tools, for boring tools, and for striking to make it. We have some different types of hammers. For holding, similarly, we have some different types of equipments. Similarly, we have a fitting shop where we can do work. So what is the main intention in fitting shop? We have different types of chisels. We have different types of files. We are finishing this product. It is the process of assembling various parts manufactured in the mission. For example, if it is in rough surface, we are making it file. Okay, so these operations usually performed in fitting shop. We can have holding tools, cutting tools, striking tools. Similarly, in electrical shop, what we are going to do is mainly we are knowing house wiring. It may be a dovetail. If it is a household wire, maybe parallel connection. It may be a series connection. It may be a staircase connection, or we can go glow one bulb with two switches, or one staircase connection with by making one switch. We can go two or more lamps like that. There are many things which are to be known in electrical shop. Similarly, sheet metal, we are making some models, maybe a funnel, it may be a square tray, it may be a cylinder, it may be any other things. And what is the thickness that we have to know? And many people don't know how to measure the thickness of a sheet. We need a feeler gauge. So, yeah, like that, even welding shop, we have welding, different types of weldings. We have gas welding, we have arc welding, we have in electrical resistance welding. Similarly, we have butt welding with some tungsten inert gas welding. Similarly, we have forge welding. There are different types of welding process also. These are very essential for the student of first year, for the first year student is concerned, right? Next, we are coming to this. Maybe designed as process of making wooden articles and components such as roofs, floors, portions, doors, windows. It starts from the marketable from wood and end with a finished product. It deals with the building work, furniture, cabinet, and of course these things are known to you. And these are the joints which I'm highlighting. A student have to study commonly used carpentry joints such as lap joint, dovetail joint, mortise and tenon joint, maybe a T joint. Both are same. And what are the tools which are required? This is I'm intendedly, I'm purposefully I'm asking you to make this. Why we are using a steel rule? And steel rule is a direct measuring instrument. It is made up of stainless steel, of course, and the edges are accurately ground, and it may be 150 to 600 mm, and the accuracy is 0.5 mm. And steel rule is most useful material in carpentry. And second, we are taking this a tri square. If you want to test the flatness of a surface, a measurement will be parallel, or it may be at an angle like that. You can make the measuring tools with tri square here. Similarly, we can have other tools like so this is a carpenter vise, where one jaw is fixed to the other jaw. Similarly, there will be a scriber making this, and divider for making different measurements. uh, Similarly, there will be a C clamp to hold the workpiece firmly, and we can use this also. And the most widely used workshop here is bench vise. So this is also called as, now in this case, carpenter vise. It consists of one fixed jaw and one mobile jaw, as I told you. Its one jaw is fixed to the side of the table, while the other is movable by means of a screw or spindle. We can call it as to a spindle. Then coming to different types of saws, this is most important. Many of you will be confused with different types of saws. And these are also called as hand saw, and these are hand saw. Apart from this, there are power saw also. Power means by using through a machine. But here in the hand saw, you have different types of saws like rip saw, cross cut saw, and many other types. Panel saw, tenon saw. This is the rip saw. The blade of the rip saw is made at an angle of 60 degrees. This is most important. For making very hard wood, we can use rip saw. Okay, for making smooth panels, and we may go for either panel or tenon saw. Panel and tenon saw. And there will be a cross cut saw here, that is used for making it is at an angle of 40-45 degrees, and its teeth have less set than the rip saw. For cross cutting, hold the saw angle at about 45 degrees. And mostly this saw is also useful for some medium rough purpose. Okay, so apart from that, there are different types of chisels. One is called as firmer chisel, the other one called as paring chisel, the other one is called as uh, I mean this paring chisel, firmer chisel, and then there will be another chisel known as carpenter's mortise chisel. Okay, so this is called as frame. Here we can call it as a tang, and this may be neck and ferrule, and of course blade. The firmer chisel is capable of doing heavy works. Usually the length of the blade is about maybe 120 to 125 mm, and the width varies from 3 to 50 mm, and this is most vital uh, chisel which is used in carpentry section. And apart from that, even we can use ripsa, sorry, mortar chisel to make some different types of holes. Mortar chisel is most, it is very rough, and for cutting edges ranges from 6 to 10 mm. We can use this type of mortise chisel. And there is another chisel called as paring chisel. The width of this it's having a long blade is very long. It is used to cut deep corners with the hand pressure only. The pairing chisel are mostly used in making patterns. In making casting, we use pattern first. So for that pattern making, we use this type of pairing chisel. This is also to be known by each students. This is what I am saying. And of course, you need to have a plane, jack plane. We are calling it as jack plane. It consists of a body. It is consists of a cutting blade. It consists of handle. It consists of a knob. So here we count as a stack or blade. We took you hold this, and this is a wooden jack plane. And of course, we can have metal jack plane also for smoothing purpose, smooth plane. And these are not in use for our purpose, for carpentry purpose. But wooden jack plane and metal jack plane and smoothing plane are most useful for the carpentry. And So what the jack plane is most commonly used for purpose. At the angle of the cutting blade is around 45 degrees here again, and the plane assembly is inserted both a plane along with the wedge. The back iron supports the cutting edge and also breaks the shavings. Of course, these are some of the safety precautions also is required while using in carpentry. The tools that are not being used should always be kept in their proper places. That means in each and every table there will be a slot to keep the hole, to keep the tools that you have to keep. Make sure that your hands are not in front of sharp edges. Use only sharp tools. A dull tool requires excessive pressure and even requires more stamina. The wooden pieces with the nails should never be allowed to remain on the floor. Be careful when you are using your thumb as a guide cross cutting grip. Test the sharpness of the cutting edge of the chisel on wood or paper. Never chisel towards any part of the body. Do not use chisels. Do not use saw with a loose handle. Always use a triangular file for sharpening the teeth. Do not use a saw or metallic substances. Do not use a mallet to strike nails. Do not use a plane as the places where these are some of the do's and don'ts which are required in the carpentry shop. Then coming to the fitting, which refers to the assembling of parts together and removing metals, as I already told you. So here we have different types of joints like square, V joint, stepped joint, and dovetail joint. These are the things which we are making, and here we are calling it as bench vise. This is a common tool for holding the jobs. It consists of cast iron, and this is called as a spindle, and of course there may be a screw is conveyed here. uh, uh, it is also having two jaws. One is fixed, the other one is mobile, and these are called as grippers. These are made with what you call it as rough surfaces. uh, then we have legwise, handwise, pinwise. Of course, these are known. And for measuring, we have even caliper also used here. But and tri-score, of course, we are using here also for making flatnesses. And punches we use dot punch of 60 degrees and 90 degrees. For measuring inside, we use inside caliper and outside calipers. Calipers are also used in the fitting shop, and you need to know about these things. To measure up to 0.001 or zero point 0.0 mm, we use vernier caliper. These are some of the instruments that we require here in case. And of course, there are hacksaw frames, which are this is a hacksaw frame which is adjustable one, and there is a fixed hacksaw frame, and two types of hacksaw frames are there, and depending upon the type we can use. And even the blades are also are different. We can make it into half edges, complete. And then files, we have flat file, semicircular file, triangular file, square file, circular file, depending upon the type of uses. And for rough, 20 teeth per inch. For bastard means it's more, 30 teeth per inch. Second cut, 40 teeth. Smooth, 50 to 60 teeth. Dead smooth, 100 teeth per inch. So as the teeth per inch increases, the smoothness also increases, and we can use rough and bastard files are used for rough cutting. Smooth and dead smooth files are used for finishing working. The file should be used in a perfect horizontal position. Pressure should be applied on the forward stroke only, not on the backward stroke. Some of the people will do like this. They go on moving towards front and back in the same scenario. But if you do like that, instead of intending direction, you'll cut it in another way, and again you are going to waste some pieces. So that is going to happen in workshop. So these are some of the things which you need to know in case of fitting. And of course, in the chisels, I told you diamond pointed, flat, half round, cross cut chisels. These are some of the chisels which is required. So just now I'm talking, this is the adjustable frame. This is adjustable frame. This is the fixed frame. And of course, in hammer, we'll have ball peen hammer, cross pin hammer, straight pin hammer, and even sledgehammer. So that is also required here in this case. And the safety precautions here we are using, you have to keep your hand tools wipe clean and free dirt, oil, and grease. Dry tools are safer to use than. Do not carry sharp tools on packets. Wear leather shoes and not sandals. Consistently we are saying this. Don't wear loose clothes, and definitely you need an apron, or at least you must have some thick clothes, uh, khaki pant and khaki shirt, like a very thick. Do not keep working tools at the edge of the table. Apply forces only on forward cutting stroke and relieve the forces on the return stroke while saving and filing. This is most important precaution that you have to keep in mind. Do not hold the workpiece in hand while cutting. Use the file with a properly fitted tight handle. After filing, remove the burrs from the edges of the work to prevent cuts of the finger. And do not use vise as an anvil. And some people will keep on going hammering by keeping it on the vise itself. It is not a good practice, because a vise is fitted to a table where it may damages. Like that, you need to have a separate vise. And anvil is there, to make different types of blows for through hammer. So parallelly you should not do on the vise. Most of the people will commit such type of mistakes, and you must aware of other things also. Next, house wiring, as this is most important. Capping may be CDS wire, cap tight shifted wire. This is the wiring that we used, and with this also we can use many type of uh, jobs. And here you need to know these are things different between a cutting player and a nose player, and what is side cutters and wire strippers. And these are things. This is for purpose of cutting. This is needle nose plier forming loops, cutting and stripping small conductors, pulling and holding large conductors, crimping wire legs. So these are four different, and we have to identify all those things. And general procedure of sheet metal. And as I already told you, we are producing many type of sheet metal. But as I know, nobody find fluid tight joint. When I asked you to make a tray square, it is intended to make a three square with a liquid tight joint. That means, of course, you need to weld even after completion of this. Maybe some soft soldering, but nobody are doing. Simply they are cutting, they are folding, and they are throwing it away, and to ask them get marks. But it is not like that. So you have to purposefully you have to do that job. So why it is given a square tray? What is the purpose of the square tray? Some materials to be kept. Even if you keep some sand, solid materials, it should not flow away. So, and if you ask to make funnel, that will be in different shape. So you need to keep some concentration here. That's what I'm saying. There will be a feeler gauge to make the thickness always. Uh, and here, what are the sheet metal operations? Means shearing, bending, drawing, squeezing, parting, punching, notching, slitting, lancing, snipping, trimming. Everything will come under this. And you know only now what is punching, blanking. That means you are cutting the piece and you are punching, and the remaining things you don't know. Deep drawing, squeezing, and that comes in the higher level. Anyway, that we'll discuss. Uh, you know about all these things. Bending, it means by the metal is stretched beyond the elastic limit. Drawing, it is the operation of producing cup shaped products. This squeezing operation, we are making forming metal. So alloying, stretching, and all those things are not required. So tools used. Most of these tools you are using is a steel rule. You are using steel rule, and of course a tri square, and some punches you are using, and uh, vice is also required. We are going to keep two vices, and bend snip is also required for you. Here it is not shown. Bend snip, you can make edges through bend snip, and you can cut even the sheet metal also. So that is most important. Then coming to this welding, uh, process of joining similar or dissimilar metals also we can join by the application of heat with or without applying pressure, or without addition of filler metal. In such a way we can go for joining. with the different characteristics of the metal. So why electric arc welding? Arc welding is the process in which heat is generated by an electric arc stacking between the electrode and the workpiece. Electric arc is luminous electric charge between two electrodes to join. So here there will be a welding mission. Usually we'll call it as transformer. So this is nothing but which controls the voltage. And one piece is connected to the workpiece, and the other terminal is connected to the electrode. Here also there are two things which we might know. When it is connected direct DC RP, direct current reverse polarity, direct current reverse polarity, and DC means here if you are not using AC current, we may use even DC current. So in that case, the polarity is very very important. And what is the type of metal that we are using, and what is the type of electrode which we are using, and what is the process that we are selecting. For example, if you are taking a metal which is of low melting point and you are taking an electrode which is of non-consumable, and then what is going to happen is if we connect electrode positive and workpiece negative, uh, that is called as straight polarity, and it will be you can perform it in usual way. Instead of that, if you connect the positive terminal to the workpiece and a negative terminal to the electrode, three-fourth of the current will come to the positive terminal and the remaining will go to the negative terminal. And before when this metal particles span on, here there will be a weld pull that is going to happen, and it is completely in wetted condition, and it is in complete position. Okay. On the other hand, if we are connecting the workpiece positive and the electrode negative, workpiece positive and electrode negative, the workpiece it consumes and it is completely without making any weld pull here, and it is going to make spatters here. So that is called straight polarity and reverse polarity. So always it depends upon the type of metal and the electrode. So when it is case of direct current reverse DC RP or DC SP, but in case of AC, because of this alternating current, uh, either you can use workpiece positive or negative. That won't differ much. And what are the type of joints which we can use? We can use butt joint, we can use corner joint, we can use T joint, we can use lap joint, we can use edge joints, and all these types of joints that we can use here. And in our shop in KSRM Engineering College, in our welding shop, we are making only two. One is corner joint, maybe a T joint. We are not asking to do much more than this. Of course, there are some safety practices even in welding. Do not weld around combustible or inflammable materials where sparks may be cause a fire, or never weld containers which have been used for storing gasoline, oil, or similar materials. Check the welding machine to make sure that it is properly grounded, as that it leads properly. Never look at the arc with the naked eye. Always you need to use goggles, or you can have a protective shield. The arc can burn your eyes because there are some infrared rays which are coming through that, and always it will be very harmful. Prevent welding cables from combining in contact with hot metal, water, oil, or grease. Avoid. Ensure proper insulation to the cables and check openings. Always wear the safety hand rules. Always turn off the machine when leaving the work. Apply eye drops after welding is over for the day to relieve the strain on the eyes if it happened to you. While welding, stand on a dry footing and keep the body insulated from the electrode. Any other parts of the electrode holder also. Now, apart from this, even we have gas welding that is not included in first year. Because of that, I have not highlighted. The thing is, you have both. Uh, in gas welding, there are three types of gas welding which we are going to get. Mostly, we prefer oxygen and acetylene as gases, with which we can produce more amount of heat. The heat can be liberated, and welding can be very proper. So that part I have not taken into consideration. So my intention is a student should know what we are going to do. For example, I asked you in a carpentry shop you are doing lap joint. You are doing mortise joint. What is the purpose of this? So For making doors, for making panels, we can use lap joint. Similarly, if you are using a mortise joint for making tables, corners will be corners will be joined or assembled through this. And for making different types of windows, we can use such a type of joint, mortar joints. Like that, you can say. Hello, hello. I'll call you later, madam. I am in a meeting. Sorry. So, like that, we need to know. Similarly, which type of welding which is preferable, depending upon the type of the material we are using. So, for example, you take a bike. In a bike, all types of weldings are there. You have soldering, you have arc welding, you have gas welding, you have all types of welding. But which welding is preferable and where, that is to be known. So, when if you know the application of that, then it will be the purpose of the basic workshop is very clear. So that for that only I have taken this part. Uh, sir,
So thank you very much, sir.
sir, can I conclude? If any doubts, they are most welcome to ask me. And my intention is to give this for the students of first year. Only our people are not giving the purpose of the tools and uses, and because of that, I have taken this topic, and it will be useful for their Viva examination also, and they are not opening their mouths. And even for the the students of electrical, electronics, and civil people are coming to the next semester. That means they are about to come in this semester, and also they might also knowing about all those things, and what is the type of wood they are using, and maybe it is mahogany, or it is neem, or it is sesame, or it is teak wood, or it may be something like that. So for this, I have taken this topic for first year basic workshop as and I'm very thankful for you for giving me this opportunity. And actually, I need to share at one platform, but you have provided me, sir. I'm very thankful. If any doubts, they can ask me.
We request the participants to please raise the doubts if you have it from your end.
Yeah, I'm ready to clarify your doubts. You are most welcome.
Yeah, sir. It seems that yeah,
Okay.
they don't have any
No
queries
problem.
from.
No problem. Okay, no issues. Okay, right.
Thank you, sir. Thank
Uh,
you, for your informative lecture for the students, especially
okay, right, sir.
the faculty.
Uh,
And we welcome such type of presentations from the top faculty of our institute.
No,
Uh,
definitely. Thing is, I will give it for a faculty next in future also, sir. And why? Because budding student engineers are most needed, but where we are not inculcating these type of things for them, and simply they are coming to the lab and they are throwing it away. And even earlier, our instructors are also very good. Now we are also facing some problems with them. Anyway, thank you, sir. Thank you for giving me this opportunity once again.
yes, sir. Thank you, sir.
Thank you, sir.
So, participate, you can give the session now, and we will continue the session technical talks from tomorrow. So, same time.
Okay, thank you, sir.
Thank you very much. Thank you.